Ever wonder how AI models like ChatGPT or GPT-4 master language so seamlessly? It all starts with the data they're trained on, vast collections of text from the internet. But here's a critical question. What if we could determine if a specific article, book, or tweet was used to train these models? That's where a groundbreaking advancement in AI research comes in. Researchers are tackling a problem called pre-training data detection, identifying whether a given text was part of a language model's training data. Why does this matter? Imagine a news outlet discovering their articles were used without consent. It's not just about privacy. It's about copyright, ethics, and ensuring accountability in AI development. But here's the catch. Most detection methods require inside knowledge of the model, like its internal parameters or probability distributions. This is called a white box approach. However, in practice, AI models are often black boxes. You only see inputs and outputs. Traditional methods fail here because they can't access the model's inner workings. Enter VeilProbe, a revolutionary framework developed by Chinese researchers. This tool doesn't need any hidden model details. Instead, it acts like a detective, analyzing how the model responds to text. Here's the trick. It feeds the model a sentence and examines how it finishes it. By studying these text-to-suffix patterns, VeilProbe identifies unique fingerprints of training data. Think of it like a translator. If you give it an English sentence, it might translate it into French. But if the original text was part of the model's training data, the translation could have subtle clues, like a fingerprint. VeilProbe hunts for these by tweaking input text and observing how the model reacts. But here's the real challenge. What if there's very little known training data to compare against? The researchers solved this by creating a prototype-based classifier, a system that identifies patterns even with limited examples. It's like teaching a dog to recognize a new trick with just a few hints, not a full lesson. The results? VeilProbe outperforms existing methods on 3 major datasets, proving its effectiveness for data privacy. This isn't just about protecting intellectual property. It's about ensuring AI evolves responsibly. As models grow smarter, tools like VeilProbe will be vital in safeguarding their secrets and our rights. But how does this work under the hood? Let's dive deeper. Researchers tested methods like DECOP, which only worked on short texts, 128 tokens, due to cost constraints. Even then, they found surprises. When analyzing longer documents, like 165 books and 50 research papers, most methods relied on averaging scores across text segments. Think of it like checking if a student memorized a textbook by seeing if they repeat phrases verbatim. But this approach had limits. Then there's the concept of intuitive indicators. Researchers explored 2 key ideas. 1. Consistency. If a text was in the training data, the AI should generate similar endings or suffixes every time. Like a student who's memorized a passage, no matter how you ask them to finish it, they'll say the same thing. 2. Semantic shift. For non-training texts, the AI has to make things up. This often leads to strange, inconsistent endings, like a student guessing the answer instead of recalling it. They tested these on 3 datasets, WikiMIA, booktection, and RZivtection. While some showed clear patterns, others defied expectations. For example, in the archive domain academic papers, some texts broke the rules entirely. The consistency and semantic shift indicators didn't always work, meaning simple checks aren't enough. So how did they dig deeper? They turned to key token selection, focusing on specific words or phrases, tokens, most critical to generating responses. But here's the catch. Most AI models don't let you peek at their thinking process. They're like black boxes. To get around this, researchers used smaller open-source models as proxies. These proxies helped identify which tokens mattered most. And here's the cool part. Different models agreed on which tokens were critical. It's like multiple students independently pointing out the same key lines in a textbook. This consistency across models suggests there's something fundamental about how AIs process language. But it also raises questions. If AIs can remember specific tokens, how does that affect privacy? Could sensitive data be accidentally leaked through AI outputs? The takeaway: detecting AI training data is harder than it looks. Intuitive checks fail in many cases, and even advanced methods require careful design. But this research is a step forward, helping us understand how AIs learn, and what that means for the future of AI transparency. So next time you see an AI generate a text, remember, behind the scenes, scientists are working to uncover whether it's spinning a story or reciting something it's seen before. Thanks for watching. If you want more deep dives into AI's hidden mechanics, hit subscribe. Stay curious, and I'll catch you in the next video.